Okay, we're going to start the semester dealing with trigonometry. Now, you've dealt with trigonometry before, way back in geometry, maybe even algebra 2. So you learned right triangle trigonometry, but trigonometry extends to situations beyond just right triangles. So if you remember back to like sine, cosine, and tangent, we will use all those things again. It just won't always be in the context of when we have right triangles. All right, the first thing that we're going to cover in trigonometry is a new way to measure angles, and that's called radians. Okay, you're used to hearing angles measured only in degrees, right? And you're very familiar with things like what 90 degrees is, and it's 360 degrees all the way around a circle. So what a radian is, if you think of it this way, a radian is how much of an angle I would have to open up in order for this arc here to be the same length as the radius of the circle. Okay, so 1 radian is the degree to which you'd have to open that angle so that this arc is the same distance as that radian, or that radius. Okay, so 1 radian is about that far. Okay, it's a little less than 1/3 of the whole circle, and I'll talk about how I know that in a second. Okay, so if we look at like how many radians are there all the way around a circle? Well, remember how we find the circumference of a circle? The circumference is equal to pi times the diameter, or 2 pi r. So there are 2 pi radians all the way around an entire circle. 2 pi is a little more than 6, and half of that is a little more than 3. Okay, so all the way around the circle there are 2 pi radians, so 6.28-ish radians. That's how many of these there are to go all the way around a circle. Okay, so that sort of gives you an idea of like where the degrees and radians match up. So let me tell you the easy places to remember. So all the way around a circle, remember we just said, is equal to 2 pi radians. And we also know that all the way around a circle is 360 degrees. So what that tells us is 360 degrees is equal to 2 pi radians. Well, we can figure out the rest from here pretty easily. If I cut those both in half, we know that 1 pi radians is equal to 180 degrees. And if we cut that in half again, we get that pi halves radians, or 1/2 pi radians, is equal to 90 degrees. Okay, now to switch back and forth, right, all that you have to remember is that you multiply by 1 to get to the other. So here's what I mean by that. So if you want to go, to convert degrees to radians, multiply by pi over 180. To convert radians to degrees, multiply by 180 over pi. Okay, now when we describe radians, it's always in terms of pi, almost always. So you're not going to usually say that the measure of an angle is 2.54 radians, right? You'll say something like it's 1.5 pi radians or something like that. I know that conversion wasn't exactly perfect, but it'll have pi in it almost always. So let me just do a couple of examples. So let's say we've got 60 degrees and we want to turn that into radians. Well, all I do is I multiply it by pi over 180. So I go times pi over 180. And notice, then what I'm going to get is 60 pi over 180. 60 over 180, that reduces down to 1/3. So pi thirds. So 60 degrees is equal to pi thirds radians. Okay? Let's go back the other way just to prove that this works. Let's say that I had pi thirds radians. All right? Well, by my chart, it tells me just multiply by 180 over pi. Well, when I do that, I get 180 pi over 3 pi. 180 over 3 reduces down to 60, and pi over pi, that just cancels. So what I'm left with is 60 degrees. Okay? That's actually pretty simple. Like converting from one to the other is actually pretty easy. Okay, so you're going to do a bunch of problems where you're just converting back and forth from degrees to radians or from radians to degrees. And then I'm going to give you a couple problems just to refresh your memory of sine, cosine, and tangent. So let me go over that just really quickly just to make sure that you have something to reference in case you're forgetting stuff. So remember the big word to remember with sine, cosine, and tangent, is SOHCAHTOA, right? And that helps you remember how to set up the trig ratios. So remember it's 3 parts, sine, cosine, and tangent. Sine of an angle is equal to the opposite over the hypotenuse. Cosine of an angle is equal to the adjacent side over the hypotenuse. And then tangent of an angle is equal to the opposite over the adjacent. Okay, and all I'm going to ask you to do today is just set up some ratios. So, for example, if we have a triangle that looks like this, right, x, y, and z, and I said, let me put some numbers in here, 3, 4, 5, and I said, hey, tell me what tan x is, you would look at this triangle and say, okay, well look, I know that 5 is the hypotenuse, and then from angle x, 4 is the side that's touching x, so that has to be the adjacent side, and 3 isn't touching x, so that's the opposite side. And then SOHCAHTOA tells me that tangent's equal to the opposite over the adjacent. So opposite here is 3 and adjacent is 4, so tan of x equals 3/4. If I asked you to tell me what cosine of y was, well, from y, now the hypotenuse stays the same, but the opposite and adjacent switch. If I'm looking from angle y, 3 is adjacent to y and 4 is opposite. So cosine of y is equal to adjacent over hypotenuse, in this case, 3/5. Okay, this is just kind of refreshing your memory so that when we get into setting up the unit circle here in a little bit, it's going to be easier to see. I think other than the converting radians to degrees, the quick setup of SOHCAHTOA stuff should be pretty easy for you, and you should be able to complete the assignment. I will see you guys on Thursday.